Hi, everyone. Thank you for attending today's webinar, Improving Program and Policy Effectiveness with Scalable Earth Observation Insights with Planet. My name is Emily Reitz, and I am the Director of Technology at the National States Geographic Information Council. If you are unfamiliar with our organization, NSGIC exists to advance effective national coordination of geospatial information by supporting state-level cooperation. We serve as a national forum for the development of capable and future-oriented geospatial leadership. If you'd like more information on how to get involved with us, please visit our website, nsgic.org. And so with that, I'm going to turn it over to our presenters from Planet today, Michelle Sisson and Matt Ballard. Thank you so much for joining us.
Great, thank you, Emily, and thank you all for joining. My name is Michelle Sisson, and I'm a Senior Industry Marketing Manager here at Planet. A little bit about my background. I was trained for policy work, so I earned my MS at Tufts in Agricultural Science and Policy. And my career was actually focused on scaling up technologies within the private sector that improve or reduce our impact on the environment. And a lot of my work at Planet revolves around state and local government. So it's really a pleasure to be here. I'm here with my colleague, Matt. Matt, can you share a little bit about your background?
Yeah, absolutely. Thanks, Michelle. Nice to meet everybody. My name is Matt Ballard. I'm a technical marketing manager at Planet. So I've been at Planet for about 2.5 years, and I work with communicating the capabilities of our platform to customers and people who are interested in Earth observation. And so really excited to join today, and I'll be running through a demonstration a little bit later. Prior to coming over to Planet, I worked at Esri for a number of years, and I got my degree in GIS. So I come from a GIS background and have most recently been working on Earth observation here at Planet. So yeah, pass it back over to Michelle. And again, nice to be here.
Great, thanks, Matt. We know that many of you are familiar with Planet already, and today we'd like to share a little bit more about the Planet Insights platform, which is something we launched about a month ago. And in this webinar, we'll start with a little bit of context around why we're seeing state and local governments turning more to commercial Earth observation data to support their day-to-day operations. And then we'll talk through this concept of broad area management and walk through some of the unique capabilities that this platform brings to geospatial offices, as well as the agencies that you partner with. And then Matt will show what it looks like to access these capabilities through ArcGIS. And we'll end with a few case studies. And we should have plenty of time for a Q&A, and let's get started. So at Planet, we are driven by this notion that you can't fix what you can't see. And our mission is to image the entire world every day and to make that information visible, accessible, and actionable to anyone. And today, as many of you know, we operate more than 200 satellites that orbit the poles every 90 minutes, and they collect data on the entire Earth's landmass every single day, or nearly every day. And we're focusing on making it easier for more government users now to access this Earth data. And this is really important because the challenges and the priorities are always changing in government, and you can often see the impact over time of different policies on the physical landscape. And depending on the type of policy intervention or instrument, you might need visibility into changes across very broad areas and also multiple timescales. And so this ability to quantify change across space and time is extremely powerful for governments. And we call this multidimensional data. So as you can see here, there's several broad policy areas, and the programs that fall into these categories typically require some type of site-specific information and then scaling that into a more expansive, high-level summary for different audiences, both within government and externally. And that data is often what serves as the evidence base to inform decisions at all stages of the policy lifecycle. So setting those accurate program targets, allocating labor, and other resources, tracking progress for internal and external audiences, and discovering maybe unexpected issues that you might need to respond to faster. And then, of course, reporting outcomes to a very wide variety of stakeholders. So we are very aware that no single data source meets all of those needs, and that you're using a very wide variety of raw data inputs, including some combination of what you see here. This is a very simplified slide, but as you can guess, public satellite imagery usually every 7 or 10 days, like aerial imagery over the country or the county or the region every 1 or 2 years, drone flights over specific areas if there's budget, and then real-time ground sensors if that's relevant, and occasional in-person inspections and visits. So the challenges that we see that are often driving people to Earth observation data or commercial Earth observation data is that when programs expand in scope or new priorities emerge, then it can expose some blind spots. So there might not be enough funding or personnel to document changes on the ground more frequently or over more areas or in more detail. Another one is that new initiatives can require a very heavy lift from geospatial analysts, as I'm sure you're very well aware, and that can create bottlenecks in various analysis or reporting workflows. We know that sometimes spatial and temporal resolution isn't always adequate to begin with, and that can impact the ability to document outcomes. And then, a reliance on manual processes as every agency is in the process of digital transformation. Some of those manual processes can lead to delays, and that in turn might leave additional problems or insights undetected. On top of all this, we know that staffing shortages, fiscal uncertainty, and all the legacy IT systems sometimes aren't making things easier. So with all that said, we're here to help geospatial offices and the agencies that you partner with work more efficiently. And we do this through a concept called broad area management. And what this refers to is this practice of monitoring and measuring and reporting changes across very broad geographies and timescales. And what it means kind of in practical terms is that governments at all levels, depending on their specific priorities, they can monitor vast areas every day. You can actually use AI-powered alerts to identify changes, and you can analyze changes across multiple time periods for greater context or insight about what you care about. And this type of visibility has all kinds of benefits for government. It can streamline workflows, saving time and money. It can reduce risk to communities and natural resources. It can improve compliance, and it also can improve or inform more equitable allocation of resources. So we're making it a lot easier for more government users to access multidimensional Earth data with this new unified experience, which we're calling the Planet Insights platform. And this essentially combines our monitoring, tasking, analytics, and planetary variables products and enhances them with Sentinel Hub, which is what we recently acquired. And so what we have now is a suite of core tools that can really help you deliver new capabilities, create the insights that you care about, and make it easier to build custom solutions around your agency's needs. So it doesn't replace what you're currently using or radically change your workflows, but it's actually designed to make our unique data sets and our unique products more accessible in the format that works best for your agency. So what it does, and this is a little bit of a breakdown of kind of in practical terms, what you can do with the platform is monitor an entire area and kind of get comprehensive insights and alerts that you care about nearly every day. And it really brings the benefits of Earth observation data to more users across government through a few unique core capabilities, or superpowers as we call them. And that can improve program and policy effectiveness. So you can look broader across the landscape, you can go backwards in time, you can get closer with high resolution tasking, and then you can look deeper with statistical and time series analysis. So I'll spend the next few minutes just quickly walking through these core capabilities, and then we'll have a demo to show you what it looks like. So the first superpower that we're going to talk about is going broader. And we know that any single area of interest really reveals part of the story. And you often need to quantify changes across an entire county or state or a special district, but sometimes there are not enough resources available to do it as frequently as you'd like. So we capture images of the world's landmass every day, which is a great way to show these larger patterns on a more frequent basis. And so that helps you, it could help you or partner organizations answer questions like, where is this unpermitted activity occurring across the entire region? Once you add another data layers, you can determine that. Do any of our lakes show signs of new algal blooms? How successful is our statewide wildfire fuels reduction program? Those are the types of questions that are very difficult to answer today, and that can be answered when you combine Planet data with your data that you have in-house already. The second superpower is this ability to look backwards. And this is important when you need to identify when a specific change or event occurred or when a new pattern began to emerge. And this is really fueled by our proprietary archive, which goes back to 2009, and public data sets, which go back to 1972. And we have new imagery added every single day. So this helps you understand, or can help you understand, what specific date or within a few days of what date was a new road or building constructed. That in turn is helpful when you need to know whether it's in compliant with laws or not. What was the extent of flooding during the last major storm? You can see that. You can see how does this year's drought compare to the last 10 years through some analytics that we also provide. So it really gives you this historical context almost anywhere across the US or the globe, as well as these deep imagery stacks for application development and machine learning based analytics. So our third superpower is really about getting closer. And often you need to look closer at an individual parcel or an area of interest, but it's too expensive, it's too time consuming, or it's too risky to get there. And that's when you can task our high resolution satellites. And so this helps you answer questions like, did this activity occur within the designated permit boundaries? How many homes were damaged by a fire? Was this construction work completed? So these are very practical questions you can answer with high-res tasking. And the last superpower is really about going deeper. And the reason we have this as our a really core capability is that we know that you often need to observe trends over time, and that we have a number of these derived data sets and analytic feeds that are really designed as inputs for advanced analysis. So this means you can answer questions really around which new buildings might need to be reassessed first, which individual trees are at risk of falling on power lines across a huge landscape, or perhaps even which trees should have been trimmed and weren't. That's probably an equally relevant question. What is the expected crop loss from a recent natural disaster? Those are the types of deeper questions. So our goal is to make it easier to get the answers that you need faster. And whether you're working with data from our constellations, public missions like Landsat and Sentinel, or you're bringing your own data, it's really centralized in our cloud infrastructure. And the platform's underlying APIs are what make it easy to query and process and visualize and analyze very high volumes of Earth data and generate relevant statistics within seconds. And we make it easy to access that imagery using industry standard indexing and streaming. So no matter where you are working and kind of what project you're working on, this can fit into your current approach, and you can embed the platform's functionality into custom applications that you develop, or integrate these tools into your GIS without having to download and re-upload imagery. So I'm going to hand it over to Matt to show you what this actually looks like within ArcGIS. Matt, take it away.
Yeah, thanks, Michelle. So super excited to run through this demonstration. Let me share my screen here. And there you go, see it shared. Okay, before I jump into the demo, I did want to just take a second to set the stage for kind of what I'll talk about. It really builds on a lot of what Michelle was just discussing there. And what I'm looking at right now is a map in my ArcGIS environment. So this map is a really simple one. It just shows southeastern New Mexico, and these blue areas represent publicly managed lands. And essentially, most government organizations who are managing public lands or managing protected areas, or trying to understand permitted activities within their area of interest, whether it's like a county or a park or an entire state, for example, in this case, they need scalable ways to detect changes across these areas. Traditional methods of doing things like sending people out to the field are not very scalable, because you simply, across these broad areas or disparate landscapes, don't have resources to send people out there with any frequency, especially because these environments are constantly changing. And in traditional imagery that you get inside of GIS environments, like the one that we're looking at here, are oftentimes out of date, right? So these are old images from months or years ago. And also they're not updated frequently, and typically just not really designed to handle broad area change detection that's relevant for like having a solid understanding of what's occurring within your areas of interest. So what Planet does differently to help manage that effectively is sort of our core capability is daily imagery monitoring. So here I've jumped over into Planet, so I'm out of our GIS now. And I'm using Planet's applications where I can really quickly just specify an area of interest. So again, southeastern New Mexico. And what we do is we have a constellation of small satellites that capture daily imagery that are right in this kind of sweet spot that's useful for monitoring change. So detecting things like new roads or new buildings or changes in vegetation. And what I mean by that kind of sweet spot is, as you can see, I've just opened up imagery from yesterday. So, and I can see imagery across this entire area of interest daily. There are clouds, for example. So, it's more of a near daily acquisition, but we're able to get very recent imagery across all of Earth's landmass. And this is essential for those change detection workflows, right? I want to be able to see how changes occur over the past week or the past month. And the other thing that Planet does that's a bit different, if you look at other sources of remote sensing data, like drones or aerial collections or other high resolution imagery providers, they're typically useful for getting collections over specific areas, but usually not for broad areas, or at the very least, not frequently across broad areas. So this frequency and this resolution that is higher resolution than, say, Landsat, for example, but lower resolution, so it's actually scalable compared to something like a drone. So right in that sweet spot that enables you to detect images or detect things across broad areas. And this application we're looking at, it's called Explorer. So this is a place where you can go to specify an area and you can download all the images that you want. And we have an integration in ArcGIS Pro that you can do the same thing. But really what you get out of that is a bunch of images, and it's a lot of work involved in going from a series of images like this, downloading them, putting them into some remote sensing analysis tool or GIS tool, and then turning it into a useful insight. It's really complicated. And so that's what Planet has built with our analytics feeds. We take out all the necessary analysis and data management that you might have to do to accomplish monitoring broad areas, and we automate it and provide you these cloud-based, much easier to use analytic feeds. And we provide these through for several things. The ones I'm going to focus on today and talk about are building detection, but more specifically road detection, and even more specifically change detection for roads. So what I mean by change detection here is we'll look at how images have whether they had roads in them previously, for example, and then only highlight for you areas where new roads have been built or where new buildings have been built. You can see some examples here before I jump into the demo, and we can share this link out after for you to see what building, road, and change detection looks like. Jumping back into Planet's application, so let's actually look at what this looks like. This application is called our Feeds Viewer. Feeds Viewer is where you can go and start to inspect these insights that we capture for you across wherever your area is. Here on the left panel, you can see imagery has been grouped up by month. It could be weekly or bi-weekly, but in this case, it's by month. And we've provided a number of detections across this whole area, again, in southeastern New Mexico. I can go and switch between these different months and inspect all of these different locations where imagery has been captured. So let's zoom in and find one to investigate further. There's a good one right here. At this location, it looks like a road's been detected. And the imagery that we're looking at below this detection, this outline here, is coming from the month of April. And if I go back and compare it to a previous month, we can indeed see that this is a new detection of some type of like a linear feature, like a road. Maybe in this case, it's oil and gas. It might be a pipeline. And this is really useful for me to see again across these broad areas because all of the detections that we've made are accessible through this app. And I can do things like filter to find only the highest confidence. So the ones that we're most certain are indeed changes through here. But this is medium resolution broad imagery. And really the goal then with detecting these is to help you make a more informed decision about like what resources to send maybe into the field to look at what's occurred, or whether to, you know, investigate a permit infraction, for example, in this case. And so we need more information than what's available within here. And so one thing that we offer is tasking. What I can do is go click on this detection and open our tasking dashboard. Here, those coordinates for where we saw something and where you've decided is worth investigating further are pre-populated into here, and I can say, give this collection a name. You can see the coordinates are populated here. We can see it on map. And when I go through these dialogues, we will actually go and task our satellites to capture a high resolution image over this area of interest so that you can get closer details and investigate further. So that's one way you can investigate these detections further. The other way that you can, and that you might need to investigate these is through overlaying all this data with your GIS data. You might have boundaries, for example, for public lands or protected areas. You might have permits actually in your GIS, and these are like additional resources that are useful for you to make decisions about how to follow up on a change that's been detected. And so Planet, we provide both APIs for you to automate, as well as OGC streaming services, so things like WMTS and WMS services that can be added directly into GIS environments. And we have an ArcGIS, direct ArcGIS Pro integration as well. So we have all these different ways for you to get our data products into your GIS where your end users are working, whether it's somebody at an agency, or maybe it's a user who's actually going out to the field to collect information in a mobile application. And so I'm going to show you, if we go back to the application, again, that's in our GIS environment, I'll kind of show you all this brought together under one environment. So here in this application, I'm going to zoom to an area where there was a detection that occurred. And all of those Planet imagery base maps are available within our GIS environment. So here, let's give this a second. Okay, perfect. Yeah. So a detection occurred here. If I click on it, I have all those details about when it was detected. It's our confidence score in it. And I can even put those links to the tasking dashboard. If you wanted to task from your GIS environment, you might want to use like those boundaries or permits as, again, information before you task a satellite. And once I've got one selected, I'll go ahead and turn on a couple of these different imagery base maps. And I can compare over time and see, okay, evidently a road was built here. And then I can search for high resolution imagery. So I'm going to go ahead and open up my map here and search and visualize imagery. I'm going to go to a different example where I know I've got a little bit better of satellite imagery that was recently captured. So in this location, we've got imagery from April 28th. So 2 weeks ago, that's high resolution. I just pick that date and it'll draw it right on the map for us. Give it a second here. Internet's sometimes a little bit slow in screen sharing, so we'll give it a moment. Maybe try a different area. Yeah, sometimes the screen share slows things down. There you go. Perfect. Okay, so this is the area of interest actually I think that we were looking at earlier. And this is a perfect example showing the combination now in our GIS of roads being detected as change detection, high resolution satellite imagery, as well as the source imagery that was used to infer that change that's occurred. And I could do something like this in my GIS. So here now this feature, this detection is editable, and I can change the status from not reviewed to reviewed, no action required, or from reviewed, not reviewed to reviewed and requesting field inspection. And when I do that, you can imagine a workflow in your GIS propagating to follow up on this detection that occurred. So that's everything that I had to show in the demonstration. We looked at sort of Planet's unique daily imagery and how it can be used in what's called tip and queue to queue high resolution satellite imagery based off of automated machine learning derived change detection. And then all of these different insights can get brought into ArcGIS through more simple integration APIs. And everything I was showing here is through ArcGIS Experience Builder. If anybody's using that application, that's an example of how you might integrate our two systems. So with that, I'll pass it back over to Michelle.
Great, thanks, Matt. So I will go back to sharing my screen. So as you can imagine, there's a really wide variety of use cases and applications within government. And one of my favorite quotes, actually, that I've heard was from a customer within government, state government, who said, the more we use Planet, the more use cases that we find. And regardless of the use case or the priority that you're trying to address, our government customers tend to see measurable value creation in 2 or 3 of these areas that you're seeing. So one is improved visibility across the region. The second is faster issue discovery and decision-making. And the third is actually the ability to do more with your current budget through the prioritization of, it's kind of spending in ways that make sense based on that new information. So we also see what I will call intangible benefits, like improving the safety for field-based inspectors who visit high-risk places, and also improving compliance and the fairness of certain programs like tax assessment for new construction. So to close things out before our Q&A, I'll share 3 examples of how governments around the world are getting value out of daily Earth data and analytics. And the first example comes from the world of hazard mitigation. The second relates to natural resource management. And the third is from or related to regulatory compliance and enforcement. And all 3 of these have to do with forests, just kind of the common theme. They're 3 very different use cases. So we'll start with a story that CAL FIRE actually shared publicly at a Planet event last year. And this is a pilot program, but we wanted to tell you a little bit more about it. So a lot of state and local governments are scaling up their wildfire mitigation and preparedness programs. And one of the many ways to do that to reduce wildland fire hazards is to reduce fuel loads. So a few years ago, the CAL FIRE set a goal to complete fuels reduction work on 100,000 acres each year. And in order to track progress, they had to monitor over 500 fuels reduction projects across 31 million acres of land. And there were a few challenges in tracking the work. One was that polygons that were manually entered by field units weren't always perfectly accurate. And the second was that the agency was working with often 2-year-old imagery, which meant that they didn't have like a really easy way to validate work as it was completed. So CAL FIRE wanted to document their progress and ensure that the public portal that showed these completed projects was accurate and up to date. So last year, CAL FIRE began a pilot project using Planet data to improve the accuracy of tracking and reporting fuels reduction projects across the state. Planet was unique in that we offered coverage across the whole state at a frequency that allows CAL FIRE to analyze how treated areas change over time, while also hitting the resolution necessary to validate that fuels reduction work had been completed. So ultimately, this really gives the agency confidence that the work that they've been doing and has been completed is actually really done. And it also helps demonstrate their progress on reaching these ambitious goals. So moving over to another part of the world, our second example is a little bit more focused on natural resource management. This one comes from the Czech Republic and has to do with forest health monitoring. So the Forest Management Institute in the Czech Republic has used Planet data for a very wide variety of management decisions. And initially, several years ago, they wanted to understand the impact of bark beetles and optimize timber harvesting practices. And the data sources that they used before 2018 really required a lot of manual processing and analysis, and also had gaps, which typically limited their ability to do any type of analysis. So the early work with Planet involved monitoring bark beetle infestations and quantifying the extent and the value of that damage. And now they're using Planet Scope data for much longer term trend monitoring and also to map the restoration of forests that were damaged from that bark beetle epidemic. We have a much more in-depth case study on this, which you can find online. You can just Google Czech Republic and Planet Labs. It should take you to the landing page to download a longer case study. So before I get to the third example, I did want to plug our partners. And the reason is that both of the solutions that we just shared were built through direct relationships with governments. And the third example was built by a partner. And we have a network of partners who build solutions for governments around the world. And they're an incredible resource, which I would encourage if you're interested in solving a problem, you want to talk to us about it, we can also help you determine which partner might be able to actually solve that as well. But here are a few that work with US state and local governments, and they're doing some really amazing work. We've seen partners use Planet data to help US state and local governments dramatically reduce the time required for initial building damage assessment after disaster, to monitor inland water bodies for early signs of harmful algal blooms, and also even to identify specific farms with the highest potential for runoff or eutrophication to support, ultimately to help support conservation practices. So there's a ton of different ways you can use partners. And this example that we'll talk about comes from Brazil, and it relates to compliance and enforcement. And this is a particular story that really demonstrates how broadening access to government users, like many, many different agencies, really can help maximize the impact. So the Brazilian federal police are responsible for identifying a very wide variety of illegal activities over the Amazon region. And in the past, agents had tried using free satellite images to monitor activity, but the spatial resolution was a really big challenge. It also wasn't captured very frequently, which made it very difficult to see changes because the rainforest obviously had so many cloudy days. So it could actually take more than a year for them to investigate various crimes and illegal activities that were occurring. And so now they actually access Planet data through a custom platform that was built by a partner, which is called SCCon Geospatial. So this video will show you an example, but really it has a dashboard with change detection alerts for things like fire scars, planting illegal crops, illegal mining, things like that. And you can see that it starts showing these labeled dots as you zoom in, and the number is the number of changes or alerts that were identified in a given area. So as you zoom in, the labels become a lot more granular until eventually you're seeing an individual detected change. And with a click, that application shows the before and after Planet imagery and the relevant metadata. And again, we see a deforestation event. This one might be different from the previous one. So SCCon integrated local permitting data, and they can characterize each alert as permitted or not permitted. And the app generates automatic analytic reports on each alert, which provides details in a format that the Brazilian government and other decision makers on the ground can use to actually see changes in near real time. And so they can save time and money on investigations. So this joint solution has won a ton of awards, and it's a really nice example of how our partner, SCCon, built a custom solution on top of Planet's building blocks. So I'm really happy to show you that. It's a very exciting one. So that actually wraps up our own content that we're presenting, but two core kind of opportunity areas that we see you can use Planet data for is to really first strengthen the evidence base. So you can understand whether programs and policies that actually play out over these broad areas are having the intended impact. And then also helping other state agencies become more efficient in directing resources, labor, so that they can use their budget as efficiently as possible. So we know every state has really unique priorities. We'd love to learn more about your needs. So I think we have plenty of time for questions.
While people are doing that, or thinking about questions they might ask, I can elaborate a little bit on that one. So the question, does Planet offer color infrared or hyperspectral imagery? We have two constellations right now of imagery. The one's the medium res that's feeding this change detection algorithm. That one's 8 spectral bands, 3.7 meter resolution. And then we have a higher resolution, the one that you tip and get the high res insights on. And that one's also in the visible spectrum and near infrared spectrum, but it's only 4 bands. So We don't have any hyperspectral at the moment, but both of those you can view as color infrared, and we are building a hyperspectral satellite called Tanager, which is going to be used by organizations for looking at things like emissions or looking at things that require a lot more spectral detail with 400 spectral bands going far into the shortwave infrared.
Nice. I do see one more question in the chat. Eric is asking about the CAL FIRE example. Can you see shrub/small fuels reduction with sufficient resolution?
I think what I'll do, I will follow up just to get a, from our team that's working very closely on this one. And I'll get back to you, Eric, but I do know that another agency in a different state is using Planet to monitor invasive grasses. And obviously that's going to be through different approach, but the resolution is good enough and the data we're picking up is good enough to monitor changes in something kind of that nuanced. So I'll get back to you with a more direct answer to your question, but I just wanted to say, like, we haven't seen a huge challenge in monitoring something yet, even a finer probably level of detail.
I guess if there aren't any more questions imminently, I know you had a few like frequently asked questions. Michelle and Matt, do you want to go over those?
Sure. Yeah, I think what one question we get fairly often is, like, what kind of documentation do you have or publications that you could, we could point you to for in terms of precision or accuracy or bias for actually our derived data products. And just as context, we have a number of what we call planetary variables, including soil water content, land surface temperature, like crop biomass. We've got the road and building analytics. We talked about forest structure, forest carbon, and we have several white papers with technical validation details. And those are specifically for soil water content, land surface temperature, and forest carbon. Additionally, we are seeing thousands of research studies, and they're published on Planet Data in general, but the academic world is very interested in our data. So we will send out those 3 white papers I talked about that are our own. And then if you have a specific follow-up question, we can always help you, find the answer on the technical validation of those. But we'll definitely send links to those white papers along with a webinar recording. Well, thank you, everyone. Really appreciate your time, and feel free to reach out if you have any other questions. Thanks a lot.